Hello, today we'll continue on the theorems. If you're just joining, go back to the previous days to catch up on the earlier lessons. Now, Theorem 5, Theorem of Tangent and Radius. We have already mentioned that a tangent is a straight line that touches the circle at exactly one point without crossing it. The important property of a tangent is that it is always perpendicular to the radius at the point where it touches the circle. Now, Theorem 6, the two tangents theorem. If two tangents are drawn to a circle from a single external point, then these tangents will always be equal in length. Another important property of this theorem is that the line joining the external point to the center of the circle always bisects the angle formed between the two tangents. So if this angle is 40 degrees, then both these angles will be equal to 20 degrees. And if this length is equal to 5 units, then this piece will also be equal to 5 units. Now, Theorem 7, Alternate Segment Theorem. This theorem states that the angle between a tangent and a chord, drawn from the point of contact, is always equal to the angle that the same chord subtends in the opposite segment of the circle. Same is true for this angle. It will be equal to this angle because this chord makes this angle at the circumference of the circle. Now, Theorem 8, Chord Bisector Theorem. This means that if we draw a line that is both perpendicular to a chord and divides it into two equal parts, then that line must pass through the center of the circle. Now, Theorem 9, Equal Chords, Equal Angles Theorem. Suppose we have a circle with center O and two chords, A, B, and C, D, of equal length. If we draw lines from O to the endpoints of both chords, then the angles, A, O, B, and C, O, D, at the center will be equal. We take any point P on the circumference and connect it to A and B to form angle APB, and another point Q connected to C and D to form angle CQD, then these two angles will also be equal. That's it for now, see you in the next one.